G'day everybody and welcome back to my channel slash my lab, I guess. I'm going to get a start on this one of the differential amplifier projects. Now this is going to be a bit of a learning curve for me because, well, I don't know that much in the RF world. I've got a basic understanding of it. You know, I understand matching impedances, I understand capacitive reactance, inductive reactance, all that sort of jazz. Controlled impedance traces. I don't know the math on it, but I get the concept. You know, the material of the circuit board, the thickness between the ground plane and the trace, and the width between the traces, and all that to give you controlled impedance traces. I get a little bit about tuned cavities and tuned cavities and tuned stubs and stuff like that for really high frequency stuff. I get the general concept, but that's about it, you know. And so I want to start learning in this area. I've got a couple of differential amplifier projects. One of them's apparently supposed to be better than this, but I'm not too sure that it is. It's that T100 differential probe that I bought that's got 70 millivolts peak to peak coupled onto its negative rail from the switching supply in it. Doesn't have AC coupling option, and it's got 2 meg and 4 meg input impedance for single and what do you call it, dual. What the hell is going on here? Dual inputs. Neither of those wires went in, damn it. Which is just odd. Like, it should be 1 mega ohm each input or 50 ohms switchable, you know, not 2 megs. So there's a few things that's going to need a whole new board made up for it. So that I might even get that one done professionally, like use software, do control impedance traces if I can't find a way of doing it by hand at home, and actually get a board made up for that. But that's why I wanted to do this one first, because this board's actually got really nice ground stitching. I don't know if that comes through on camera. It's got really nice ground stitching, and it looks like control impedance traces, or at least like they've done a half decent job of it for the frequency range that it's spec'd at. So what I wanted to do, I don't really need to put it in a box for the first measurement. The first thing I wanted to do was just see, I'll show you the listing for it. I've got the data sheet for it. Excuse me, I'm just getting over this cold. Still got a little bit of a blocked nose. So that's what it is. Nice and cheap, that's why I grabbed it. It's a genuine chip on there, I have checked it. And that's what they say in the listing. So what I found appealing was the high CMRR, but it's only DC to 100 kilohertz. So 80 dB minimum, 2 megahertz, 70 dB, 10 megahertz. Okay, so it's still pretty good. That's good. Okay. Now here's what I don't know. So like, let's just look at another random data sheet for something that's totally different, right? But you see here it says that for gains of 1 to 20, it can maintain a 50 megahertz bandwidth. What my question is as the gain gets set higher and higher on this, at what point, you know, it says that it's 270 megahertz, 1090 volts per microsecond slew rate. That's damn quick, but with a gain of 1, if I put a gain of 10, would I still have that? I'm sure the slew rate would be different, but would I still have that bandwidth, or does that drop? So if anyone is, you know, into RF and can answer that question for me, I'd really appreciate it. I do have the data sheet for it. Here we are. So, you know, I've got to try and read it, but like I said, I've got a lot to learn here. I'm just getting into the high frequency realm of things. So, yeah. Anyway, what we're going to do first is I've got the output going into my scope and I've got the inputs ready to go into my ARB. I'll just pause and put this in a tripod. Alright. I've already set everything up ready. So I've got one channel inverted 180 degrees and I've got just a 1 kilohertz 500 millivolt peak to peak signal on each channel. One 0 degree phase offset, the other, can you guys see that screen? Oh, my apologies. Yeah, I can't really get that clear enough. I'm sorry about that. Okay, let's just go for it. Now this thing's got ridiculous phase alignment issues, so I have to set everything first and then turn the outputs on. And if I touch a button, literally even just hit the menu or go between the channel options to set something, it'll completely screw the phase up. I'm getting the runaround with Owen, which has pissed me off because apparently they've given other people, the first units they made a couple of years ago have got some software flaw in it where the phase, it's just terrible phase offset issues and it doesn't lock phase, and when you go into the menu and lock phase, by the time you've gone back out the menu it's already lost it just from pressing a button. It's just totally flawed. And they're replacing people's units that have got that issue. Me, when I first emailed them, I can't even remember, they just asked me all these dumb questions, like trying to make me feel like an idiot that didn't know what I was talking about. And then when they realised I did know what I was talking about, they go, oh, what's the serial number? So I told them the serial number, and then they go, sorry, that's not one of our units. I'm like, it's one of your units. I bought it from you. You know, I'll take a photo of it. They asked me to take a photo of it. So I took a photo of it and took a photo of the serial number. And then they reply, thanks for purchasing Owen products. I'm like, yeah, okay, can we get back to the conversation at hand? So I emailed them again. I'm like, yeah, okay, so do you agree it's yours? What can we do about this? They're like, can you upload a video? This is their response email. Can you upload a video to this? They shared me some link of some file upload thing. They go, can you upload a video, showing the phase alignment issues? I go, yeah, sure, no worries. It's just pissing me off. Like, why do I have to go through all of this when other people apparently are just emailing them? They're obviously asking for the serial number. They know what batch, up to what version has this problem. So as soon as I've given them the serial number, they must know, yeah, it's an older one, it's got the problem. But they're still doing this crap. It's like, come on, guys. So they want to play ball, that's alright, I'll play ball, and they're going to lose because I can prove it. So, anyway. And incidentally, that's got nothing to do with the USB issue. That I caused. Technically, I caused it, but realistically, it shouldn't have happened. But anyway, that's debatable. Not by my standards, but by some people's standards. Anyway, so I've got 500 millivolts peak to peak on each output. I should have a volt, not 912 millivolts. You see, I literally just pressed the button to go between the two channels and you saw that jump, and now it's at 768 millivolts. because it's got phase problems. So I don't know if this makes sense, but look, if I turn both the outputs off, God, this is confusing. This is so stupid. Literally just go to phase and just act like I've just said it. Go to the other channel, go to phase, act like I've just said it. Go to utility, go to channel, 1, 2 set, go align phase, and then without going out the menu, just turn the outputs on. 1 volt, exactly. You saw that. And then it went back to 992 millivolts. 1 volt. You see it's flashing? Like, come on. And you hit the back button out the menu. Okay, hasn't changed yet. Go out of utility. Hasn't changed. Let's not change the setting. Let's just look at, not channel 2, look at channel 1. Oh, 656 millivolts peak to peak. You know, like, you've got to be kidding me. And they think it's going to be hard for me to put 2 channels into a 4-channel scope and show 2 channels at the same time and the phase correlation between the 2. They've got another thing coming. They'll be getting that video tonight or tomorrow. Anyway, now I've got to do this again. I just wanted to get that on camera because I feel like some people probably think I'm talking smack, but no, this is an actual problem and it's just bloody ridiculous. It should not be like this. See? I can't touch it. What the hell? Anyway, so we do have 1 millivolt coming out with supposedly 180 degree offset signals that are 500 millivolts peak to peak going in. So that was my first test I wanted to do. I'm happy with that. It does what it's advertised to do. So that means the gain resistor on there is for a gain of 1. Actually, that's not what I want to disconnect. I want to disconnect these now. So the next thing I want to do is I want to see what its noise is. First, I'm going to test it with the inputs open, but what I've done is I've got a 9 volt battery here. You know, even the cable I've twisted up on it. Came untwisted on the bench, but right. And I've got a box with a piece of paper in the bottom of it. And I'm going to sit this in said box, like so. On camera. Yep, cool. I'm going to put the lid on the box. And that'll do. Wow. Open inputs, it's got 800 microvolts RMS and about 8 millivolts, 8 millivolts peak to peak. Alright, what I'm going to do, I know this isn't ideal, but I mean, I don't really have a shorter way. Actually, it is ideal really because I don't have an SMA connector, so I'll just pause the video, turn my soldering iron on, and I'll just solder a blob of solder between grounds to input off on both the inputs, and we'll have a look at how much noise is coming out of it then. I won't bother pausing the video, it'll only take me 2 seconds, I'll just do that right now. My soldering iron's just coming up past 280, 290, 300. We'll be melting solder in a sec. Alright. So I'm just going to solder the inputs. Don't worry about that on the scope, that's just a, what do you call it, ground loop. Okay, that's both inputs completely bridged. Now that's jumping all over the place, and what I've done is I've just bridged the inputs. I find that interesting. Unless that's heat, that might have just been heat or the capacitor's discharging. We'll just give it a minute to settle in this box. It does appear to be settling okay. I think that was the capacitors from the heat travelling through the board. Or maybe there was some current on them that was discharging too. Or a mixture of the two things, most likely. Okay, so that has settled down to let's call it 2.5 millivolts peak to peak and 250 microvolts RMS. Alright, so my next question, if anyone in the RF world is watching this, what can I do to get this down to a smaller figure other than running off a battery in a shielded enclosure? Which, you know, is not really making much of a difference anyway. It would if there was a noise source in here, but there isn't right now. But I mean, obviously you wouldn't run this out of an enclosure. But and no doubt, if I got down to around 50, 40, 50, 60 microvolts, then yes, the enclosure would be necessary just to be able to see that. But my question is, what's generating this noise? Because this is a wideband high frequency noise, you know? Probably should have gone up a bit. So it's actually about 2 millivolts peak to peak and about 230 to 240 microvolts RMS. Although it's probably more accurate up here because it's averaging it a little bit better, because it can see more over a longer period of time. Even at what are we at, 1 millisecond? Even at 500 microseconds, we've still got 237 microvolts and 2.4 to 2.5 millivolts peak to peak. It's quiet, but you know, it's fine for audio or running signals around or whatever. But what I want to build is a differential low noise amplifier out of this. So if anyone knows what I can do to get the noise floor down on this, leave it in the comments section, because that's all this video is me asking those two questions, basically about the gain, the bandwidth as I go up in gain. I just wanted to put a switch on it for ×1 ×10. I was happy with it being AC coupled. The other diff probe that I've got to modify, rebuild, that I want to add AC DC switches to, but this I'm happy for it to just be AC coupled. So there's a few things I wanted to look at on here, like there's this provisionment on the board for V offset just down here. You know, I probably will take a look at the output and see. Let's do that now. We've got a pretty accurate meter here on the bench, as a matter of fact. Let's take a look at offset. I'm just trying to find something that's short and thick. I don't really have a shielded cable that's going to go from this to this, so it's not going to be the most accurate reading, but we'll get an idea of DC offset. Really? Wait, is that just slowly dropping down, or? Okay. I might want to do something with those V offset pins because I want the offset voltage to be as nulled out as I can get it, obviously. And I do believe, even though I haven't had this meter calibrated, I do believe it's pretty accurate, especially at least down the bottom end near, you know, in this range. There's a complete short, you know, so I'd say it's accurate at 6 millivolts, you know. So I kind of believe that offset is actually there. Again, leave it in the comments section if you know. But that's what I wanted to look at, was I wanted to look at what kind of capacitors are on here. Should I put better capacitors on there? There's 2 resistors on here. Should I go and get low inductance resistors? And, you know, is there something I can do with maybe the power line decoupling or the V offset trace and the comp pin to maybe get rid of stray capacitance and stuff like that? That's all I can think of in terms of making this thing better. I really don't have a clue as to how to make it any quieter, so that's what I'm kind of asking if anyone knows. I'm going to obviously, in between now and the next video, do my own research on this, but yeah, this is the next project for me. And it's going to go in this box. I should point this out too. This is just for testing. It's going to go in this box and it's going to be mounted with BNCs mounted to the box. So I just want this in the box with BNCs and a switch on the top that can select between 2 resistors, you know. I don't think I'll have a problem doing that because I can just sort of basically solder another resistor that's the 10 times the value of that one or whatever to get the gain of times 10 or whatever. You know what I'm trying to say. I can just solder a second resistor off the end of that one and run some shielded cable, like 2 wires in a shield or 3 wires in a shield, run the shield to the ground plane and use the 3 wires to switch between the 2 resistors and put a switch on the top case, you know. So I was going to do that and put BNCs on it and put it in a little box, but I want to get the noise floor down. So, and I also want to know what sort of bandwidth I can expect out of it if I do turn the gain up to say times 10. So if anyone does know about that, please leave it in the comment section. I'm very curious. Yeah, that's all for now. I just wanted to have a quick look at it basically. And just for anyone that's interested, I'll just go back to the data sheet. Oh my god, I'm sorry. Let me just unlock that. I don't want to blind anyone. Alright. So, by the way, this is the 8130 I've got. So it's worst harmonics at 5 megahertz, minus 79 dBc. Oh, no external components for gain equals 1. Well, that interests me even more because there's V offset, but then I get one of those capacitors has got to be for the compensation pin and the resistor with it, but what's the other one for? Oh, that's with the V offset. I wonder if I remove those 2 components for the V offset pin if it gets quieter. I also wonder if I can put a resistor value there to ground and it will bring the V offset down, or if I have to add voltage there. Anyway, that will all come up in the next video when I start playing around with it. I'm hoping to, you know, get a bit of research done in the meantime and hope that some of you guys might be able to give me some feedback in the comment section about the things I've asked. And then by the next video on this, I will be better armed information-wise and be able to make a better choice as to where to proceed with the build. So I'm basically just trying to take my time on this one. I'm going to start on a few other things now. I was actually getting curious about that Yamaha mixer. I was going to take another look over the schematic on that and possibly have another look at that. I've got a few ideas that have just popped into my mind the last few days thinking about it. And I've got a few other things around here that I haven't even started on yet that I want to get started on. So yeah, going to be doing a few little things here and there whilst I'm trying to sort this out. I want to take my time on it. I don't want to muck it up, basically speaking, and it's a learning curve for me. So yeah. Alright, that's all for now. Thanks everyone for watching, and I'll see you soon.